Hi and welcome to another episode of Haxe React. When it comes to web development, React is everywhere. It has a huge community with tons of tutorials. It has great tooling with Webpack build tools, with live reloading and package management and whatnot. Using the Create React App tool, we can get going in minutes with a basic React application setup. Haxe, on the other hand, is a great programming language that gives you lots of features that JavaScript hasn't. You can use Haxe to generate almost anything. You can generate native solutions with C++, or you can generate Python or Lua, or in this case, JavaScript. In this episode, we will have a look at how we can try to tie these two ends together. We will start with a basic JavaScript React setup, and we will build upon that using Haxe to generate the code for us. Here's a quick overview of what we will cover in this episode. Starting with the standard React setup, we will tweak this setup to give us a live reloading of index.js edits. We will set up a Haxe project to generate a replacement for the index.js content using Haxe. And we will also use a new library called Watch to autocompile the Haxe project when we save the Haxe source files. We will have a look at how to use basic functional components in Haxe React, including hooks. We will have a look at using class components in Haxe React. And last but not least, we will have a look on how we can use a tool called DTS to Haxe to generate externs for third-party React libraries. Here's a quick overview of the tools and versions that I'm using. If something doesn't work, please have a look here and check your versions. It might depend on some of your tools being older or newer than the ones used here. Also, big thanks to the great Haxe community for helping me out with a lot of this stuff. Special thanks to Philipp Elsas, Kevin Jung, Rudy Gers, and Uri Kirchheim. Also, big heads up for the MVC Coconut project by Uri. If you're interested in Haxe and React, you should definitely check this out. It's architectured around the same principles as React, but being built with Haxe from the ground up, it gives you more Haxe idiomatic features. Also, a big disclaimer here, I'm not at all a React expert or a Haxe expert. What I'm presenting here is just my experiences with trying to integrate Haxe into the standard React JavaScript workflow. So we start by opening our terminal and running the following command: npx create react app and the name of our project. After navigating into our project folder, we can start the development server by writing yarn start. This should kick off our brand new React application running on localhost port 3000. Then we can start VS Code in the project directory by writing code dot. We can then try out live reloading by navigating to the file app.js and try to edit the content there. And when we save it, the application should live reload. When we try to do the same for editing index.js, we will find that it doesn't work. That's because of some changes introduced in version 4 of React script library. So to make this work, we have to revert React script to version 3.4.4. We do this by first removing the current npm React script library and installing version 3.4.4. Just two more things to do before we can start editing our index.js. We have to copy the import React statement into app.js. And because of the changes in React script, we have to restart the development server. Now, editing the index.js file gives us the expected live reloading. Before we start using Haxe, we can tidy up things a bit. We can clean the index.js file, and we can remove the redundant JS files from the source directory. So now let's move on to Haxe. We start by creating a new local repo for the Haxe libraries. Then we can run haxelib install React. This of course will install the Haxe React library, but also its dependencies. We also need to create a Haxe compilation file called build.hxml. Here we start by defining the compilation target, which of course is JavaScript in this case. We want Haxe to generate our index.js located in the source folder. We also need to tell Haxe where to find the Haxe source files. And to keep it simple here, we use the same source path. And we also have to tell Haxe where to find the application entry point, and we will put it in index.hx, so our main will be index. Finally, we can use some compilation parameters to define the optimizing and styling of the generated JavaScript output. So now we need to create that index.hx file, and we just put a simple function called main in it, in which we put a simple trace that will write to the console. We can then compile our Haxe project with Ctrl+Shift+B. This generates an index.js, but we also encounter the problem that the JavaScript linter doesn't like our index.js. We could of course mess with the linting configuration, but I will take the opportunity to introduce a simple Haxe compilation macro solution. In the project root folder, we create a file called nolinting.js, and in that file we put the ESLint disable statement. The purpose here is to get the Haxe compiler to include this ESLint disable statement at the top in the generated index.js file. For that, we use a Haxe compilation macro called include file by adding the following line to the build.hxml. After saving and compiling, we can have a look in the index file, and we will see that ESLint disable statement at the top. Now, when we have disabled ESLint, the project should auto-reload and we should see the trace in the console. Now we will have a look at a way to get automatic recompilation of the Haxe project when we save an edited Haxe source file. For that, we will install a haxelib library called watch. It is created by Ben Merks, and please go and check out his GitHub page where you can find detailed information on how to use it. To kick off watch, we open a new terminal in the right directory, and we just write the following: haxe build.hxml -lib watch. To make sure it works, we can do edits to the index.hx file, and when we save it, watch should compile the Haxe project for us, and because we then get a new index.js file, it should be auto-reloaded in the browser as before. So, time to add React as a library dependency in our build.hxml. I'm also adding some compilation flags here, for example for fragments and for using the context API. You might not need them, but I choose to include them here anyway. When working with React views, we always need to import stuff, for example the JSX method that lets us write our HTML-ish render code. We also need to import the React components, etc. Instead of including these import statements in every single module that we write, we can put these statements in a single import.hx file that's global to the package directory that we're in. So now we can write our first Haxe React code. Just as when we're using vanilla.js React, the React DOM.render method takes two parameters. The first is a JSX code, including the view, And the second one is the target element where we want to render the view. Because we're using the JavaScript Webpack setup, we can dynamically include CSS files. In Haxe, we do that by referencing the CSS file using js.lib.require. This is very handy as Webpack auto-reloads the CSS files for us whenever they're changed. Time to create a component using Haxe React. We start by having a look at the simplest functional component that we could possibly write. For that, we simply create a function from which we return JSX view code. Please note that the function name first character must be uppercase. When we have created our functional component, we can use it in the JSX code. To pass attribute parameters to our functional component, we wrap them into a parameter object with the root name of props that we pass into our functional component. To use state in a functional component, we need to use the useState hook. Thanks to a clever solution from Uri Kirchheim, we can do that in Haxe React in a very nice way. For that, we need to create a React package in which we include a React hooks.hx file. To get the content for this file, please check the links below. To try this useState hook out, we create another component called clickCounter. It's a simple button that will keep track of how many times we've clicked it. As before, we create a functional component with the name clickCounter with capital C in the beginning. And we return the JSX code including the button. To keep track of how many times we've clicked the button, we create a state variable called counts. And we set the default value for that state to 0. Now we can get and set the inner value of this state called counts using a property called value. This is different from how we would deal with it in plain JavaScript, where we would destructure an array and get two elements, one value, counts, and one setter, set counts. If we have a look in the Haxe code, we can see that this is taken care of in a type-safe manner using an abstract with a getter and a setter for the value. After saving and compiling, we can see the button with the 0 printed out. But we also have to add a click handler to our button where we increment the counts value. So let's have a look at how we can use class-based components in Haxe React. We start by creating a components package folder and a test.comp.hx file. Because we will be using both typed props and state in this example, we start by defining them as typedefs. Empty for now, but we will give them data fields in a minute. Then we define our test.comp class, which extends React component of and as type parameters the props and state that we just defined. Then we add a constructor method that takes in the props and also defines the default state. Every React component should override the render method, and from there we should return our JSX view. To keep track of what we are doing, we can use a view that prints out the props and the state for us, but please note that we can't render objects directly. We have to convert them to strings. Here I'm using the Haxe standard library std class as static extension. This makes it possible to stringify anything just by adding .string. We can then make sure that our import.hx file references our new component, and after that we can include it in our application. As an alternative to importing CSS files, we can also style the individual elements directly. For that we use the style attribute, in which we put an object with the style properties that we want to use. Please note that because it's an object, we need to use camel case field names and values as strings. So let's pass two props to our component, one called name of the type string and one called age of the type integer. This lets us use these as attributes for this component. To illustrate the use of state in a class-based component, we will use an input field and keep track of the text in that one. We start by adding a text field and setting its value to something. When we compile and run, we can't write anything in the input field, and we also get an error message from the JSX compiler complaining that we don't have an onChange event handler. But before we implement that one, let's give the component state a text field to keep track of the text. We set the state text default value to something. And instead of using something hard-coded for the input value, we can now use the state text field. To be able to change the text, we need to add the asked for onChange handler. In that one, we will use the setState method. That's a part of the core React component methods. It gives us the current state with the state parameter input, and we return the field or fields with the value or values that we want to update. Sometimes we need to access the actual DOM element that React creates for us. For that we can use the ref attribute. As parameter, it takes a method that passes the actual element to the function. Of course, you can override any of the React component lifecycle methods to deal with mounting and dismounting of the component, to deal with props changes affecting state, and so on. We will finish this episode by having a look at how we can use third-party NPM React component libraries from Haxe. For that, we will use a library called DTS2HX. This will take the TypeScript type definitions and generate Haxe externs from that. As an example, we will use the React menu library from Haxe. It's a simple and useful library for creating user interface menus. To start using it, we add it to the setup with the command yarn add @haxe/react menu. We also need to add the DTS2HX tool itself to the setup, this time as a dev dependency. If we have a look in package.json, we should see the 2 entries for the libraries that we have added. Now it's time for letting the DTS2HX tool doing the hard work of creating Haxe library externs for this React menu library. The tool does its job very gracefully in this case and puts the fresh externs into the haxelib folder. To use these fresh externs in our Haxe project, we have to add the externs as a library dependency in our build.hxml file. We will use the basic example code from React menu site, and we will copy the imports from there and also copy the render JSX code. As usual, we add the import statements into the import.hx file, and we can see that the conversion tool has done a great job. We can find the imports where we expect to find them. Before we start adding the menu to the test comp, we will clean it up and take away the ref stuff and so on. We can now copy the basic example JSX render code and paste it into our test comp render method. We need to modify the render code just a little bit to make sure that every JSX statement is wrapped into a JSX function call. We also need to import the React menu style CSS file. Just as before, we use a js.lib.require method for that. And that's all we need. After saving and compiling, we have a working React menu implementation. Big thanks to George Corney for making this possible by creating the DTS2HX tool. Thank you for watching this episode, and until next time, bye bye.